Today I'm going to talk about how you can quit writing everything yourself. I work at help.com and I've got like my Twitter and GitHub or whatever up there, but at Help I'm an Node engineer and I'm a member of the core technical committee and I help cut Node releases as well. Just a little bit about me. But we can go ahead and dive right in. So one of the biggest things for JavaScript developers one of the things that I see quite often is that we have to do a lot of input validation, whether that be validating like throughout the life cycle of an HTTP request. There's request body, query string parameters, headers, response bodies. You want to make sure that you're getting and receiving the data that you're expecting. And so that takes a lot of time to write that same code over and over again. A lot of it's, is this a string? Is this a UUID or an array, that kind of thing? Then there's also like function arguments. So say you have a function that takes an options object. You want to make sure that the options that are passed in or the properties on that object are what you expect them to be. And then another pretty common input validation that we do is for message format. So like sending data over TCP, UDP, things like that. So it kind of ties back into the request and response as well. So that gets really old really fast in my opinion, just writing the same thing over and over again. And so at Help, one thing that we tried to come up with is how can we automate this and keep all of our developers from having to just write this mundane code over and over again. So we want to be able to validate an object's properties for different types, different values, things like that. We also want to be able to enforce how something is written. We want to make sure we're not doing something synchronous inside the lifecycle of an HTTP request and that kind of thing. But this is important in many ways. One being the different types that are in JavaScript, like type of array is going to return an object. Type of null is going to return an object. So these are checks that a lot of people know to make. Some people are still learning on that. And if they don't have to write that every single time, then we can, and we can generate that, then we can guarantee like this is written in a way that is going to perform for us how we expect it to. So how can we enforce that besides linting? Linting is kind of the first obvious thing, but ES CodeGen is a somewhat popular package that allows you to pass in, well, from the README, it's an ECMAScript code generator from Mozilla's parser API, AST. So it takes in an object or an array of objects that define the standard format, the ES tree format of how you can represent JavaScript code in AST, which is an abstract syntax tree, sorry. So this is just a little site that I have that shows the actual code and it's parsed to show the represented AST. So 4 plus 5 generates a lot of stuff. You have an expression statement that has a binary expression inside of it. The left-hand side is a literal with a value of 4. The operator is the plus, and then the right-hand side is a literal with the value of 5. That's a lot for 4 plus 5. But this is more of one of the more basic types of binary, or one of the more basic binary expressions that you see a lot. So how can we make this easier? We have been doing more code generation at Help lately, and one thing that we noticed is when using ES CodeGen is that you pass in these objects, and when you don't pass in the correct thing, you don't get the best error message. So that's part of what we've been working on, but we've also been trying to come up with a way to make it easier to construct those objects. Knowing what exact property, there's lots of different types of nodes in JavaScript, so knowing what to actually pass in it gets complicated pretty fast, lots of lookup. So we tried to make something that allows us to not generate as far as generating code, but to construct these objects that we pass in without having to remember all of the properties, just to make it a little bit simpler. So this is actually something that we've open sourced today, and it's available on NPM, but we can kind of go through it to see what kind of benefits we get out of it. So say this is a function that we want based on, based on different kind of configuration that we pass in. So we say we have an object like a user where, you know, we have the user's name, we have their email, maybe a display name, lots of different properties. Writing each one of those, you know, if type of name is not a string, you know, return an error, that gets old. So how can we take that configuration to build this using build AST and ES CodeGen? So this is what we want here, and this is just a, you know, a simple example as far as the validation goes. But, you know, once you get multiple properties on an object there, it gets pretty long. So to use build AST, you first require it, and then you can call it, and that will create a new builder. And as you can see on line 6 here, we're calling use strict, so we're going to put the entire file in strict mode. And then for, say we want to do type of ops.name equals string, or does not equal string. So we can do builder or b.typeof, and that will create the object necessary to create a unary expression for type of, and then we can do b.string, which will create a string literal, and then we can pass both of those as the left and right to not equals, and that's just going to be like not equals. Then we want to create a new type error if that name is not a string, and so we can do just b.typeerror with the error message there. And then we can create the block inside the block for that conditional statement where we're checking the type of. So we're going to declare, if you look on line 25, in the error block, we're going to declare ER as the type error, and then we're going to return set immediate, calling the callback with the error. And so .build here returns an array of AST nodes. It allows us to use builders nested inside of other builders. Tends to make things a little bit easier from what we've seen. So here is the actual block that we're generating for this function, and we're doing an if statement with the check, which was the type of check, and then we're going to wrap that error block in a block statement, and then we're going to also return calling set immediate the same way that we did for the error. Then down at the bottom we'll call b.module, and we're going to export a function called validate with ops and callback as the arguments there. And then you can just pass in b.program and call that to ES CodeGen generate, and that will generate the code for you and output a string. So finally we get to build it. And that brings up the actual validate function that we export. So I know with a single property, it's like, hey, we had to write more code than we would end up having to write. But you know, once you have these multiple request responses that share these same properties, it gets old writing the same thing over and over again. So that's one thing that has really made it easier for us to really write, you know, APIs and that kind of thing faster. We also use them for validating arguments to functions as well, like I had mentioned. So it can save you a lot of time, but being as we can do it in a config-driven way where we're passing in like, hey, we need these properties with these types. This one can be null, this one cannot be null. We can actually generate the documentation for that at the same time. So not only are we not having to write that code every time over and over again, we're also not having to write the documentation for it. So we can generate that part of it and save a significant amount of time. So I guess I can show that actual one. This is the full file here. Can y'all see? A little bigger? Is that better? More? Okay, cool. So we require our builder here, and this is the same code from the slides, but it shows them all together. And I tried to make it comment a little bit, but yeah, we have our builder, and we're constructing this same type of check here. So this is the full file, and we can go ahead and run it and make sure that it works as we're expecting it to. So yeah, it just outputs the code for us. It's nice. Sure. Can y'all see that? There we go. This actually doesn't build documentation at this point. We do have tooling that we're trying to get ready to open source. This was kind of the one of the first Legos that we built to allow us to generate the code and the documentation. But we do currently build both. We generate code and documentation for all of our APIs using build.ast, which has been a pretty fun experience. But yeah, that was all I had. Did anybody have any questions?
So with TypeScript coming up, like, would we still want to use something like this, or because it gives us pretty much all the strong typing compile time check that we want even before the code is run?
To be honest with you, I feel like there are different goals. I know for us, we are not looking to have a strongly typed language, but we are looking to be able to make assumptions about our route handlers and things like that. Like, hey, this isn't going to be called unless all of these, unless the validation passes, which I know TypeScript does give you in a lot of cases. But yeah, I think that there are just two different ways to achieve similar goals.
Right.
So.
And the other question that I had was, what if you write or auto-generate the schema of your object, and then just pass that schema and just write type validation functions one time in your runtime, and depend on that and call it a day?
That is definitely something you can do.
So that gives you like JSON schema validation for all the JSON objects that would be passed between the client and the server. And you can keep on adding more functions over there for new formats or UUID, date time formats.
Sure.
Base 64 URL encoding, etc., etc.
Yeah, we could definitely do that. That's definitely an option. One reason we do like the generated, and I guess you can generate documentation from the JSON schema as well. Just a different way of doing it, to be honest with you. They both work. One thing that this does allow is these functions are specific for each request body, each response body, and so that allows us to not be dynamic, and so we do get a little bit of performance gains out of that, but to be honest with you, it's more minimal than anything else. So, but yeah, just multiple ways of doing the same thing. So this was one way that we liked and we experimented with and were able to iterate on pretty fast, and it's worked well for us. What's up?
Yeah, I think one of the differences may be interesting to see if you can show them kind of the nanoprop stuff and how that gets converted to this. You'll see the difference between JSON schema and this. And one thing about JSON is that it's really easy to mistype in JSON and you get completely the wrong thing. So we actually use JavaScript rather than JSON to define our objects.
Yes.
And that way you have actual type checking and things like that. And then to address when you're thinking about like what's the difference between this and TypeScript, TypeScript isn't going to tell you like what a regex matches for an input or like what the string length of is. So you can use this for like type validation, but it's also things like, what's the length of a property or what's an enum or these types of things, which are going to go well beyond TypeScript.
Yeah. So here's an actual example of one of our route configurations. Let's see. We can do like creating an organization. So we have this package that we use internally called nanoprop, and it allows us to represent these properties as in JavaScript. It really just creates a JavaScript object, but it allows us to create, like this is a string, and we can give it a path. We can also nest them this way. And so when you're going through, like this is significantly easier to write than if type of admin does not equal object, if the email in the admin object is not an actual valid email address, that kind of thing. So that kind of goes into detail about why we're using it to generate. But yeah, it's cool. We can validate nested array values and properties inside objects and nested arrays and things like that. So this is the first of hopefully many of our packages that allow us to do this that we're open sourcing.
That is great. I'm pretty much doing something very similar. I'm into the business of generating client-side code from Swagger specs. And your Swagger specs, in the model definitions, you have all your JSON model definitions, right? So I create a mapper, and that mapper has pretty much all these niceties like min length, max length, regex pattern. And then I take that mapper, and whatever the user is going to give me, it's mostly a JSON object. And I try to map the JSON object with the mapper. If it fails, then I give back the right error. So yeah, this is pretty much the same thing.
That's awesome. Yeah, we're using it for generating client code as well. So it kind of allows you to automate more and more the more you buy into it, which is nice. Because we do use a microservice pattern, so writing those client packages for it just gets repetitive. So cool. Are there any other questions? Cool. Well, thanks. I appreciate it.